try hacking machine that we have copied. Just so see, we got the ping request, so we do know now that the machine is alive. Moving forward, uh, if we don't get a response while ping, what happens then? It might be a firewall, or that machine might not be alive at all. There might be no device at that IP. That's and like consider here's only an IP, but what if do we have to scan a whole network? So there's a thing called networking. So basically, you have to know little about networking. What are networks? What are subnets? What is broadcast ID? What is network ID? All this stuff to get to get into scanning. You have to know networking before. Okay, so this attack called ping sweep attack. So in ping sweep attack, you send a ping request to every possible IP address in that subnet or in that network. Okay, so how does a ping sweep attack is performed? So basically what we're gonna do is type nmap. Nmap is a short name for network mapper. It's a network scanning tool and basically a very strong tool used from a past long time. So device what we got that we perform, sorry, not device, for a network. So 24 is a CDRI or CDIR. I don't know exactly name, but yeah, it's the CIDR. Sorry, yeah, got it. The CIDR mask for that, and it's the Nmap is gonna scan all possible networks in that CIDR. So we got some hosts up. Out of 256 IP addresses, the Nmap scanned 256 IP addresses, and there are, we can see, 8 hosts are up. So that's how a ping sweep attack is performed. Now, moving to the second method, we do have to check for open ports. What ports are open? Like if we select an IP address that is 214 that we can see here. So what we're gonna do is check for open port. Just type nmap and that IP address. Press enter and we will scan automatically what ports are open on the IP address. So we can see here port number 21 is well-known port reserved for FTP services. Then there is uh, port number 80 for HTTP services. HTTP services are basically websites. Then port number 139 and 445. This is basically a SMB share. SMB is just like FTP for Microsoft, you can say, somewhat similar. The third method or third step in the methodology of scanning is evading IDS. IDS is an acronym for Intrusion Detection System. So first of all, we discovered the target, what device to target. Then we uh, perform the scan on that target to see what doors are open and through which door we can walk in into the target. Now what? Now assume there's a building you want to enter, but on the gate there's a security guard. So how will you get past him? Okay, so there are basic methods of evading IDS. I'm gonna talk about few. As a part of scanning, basically, it is important to evade the IDS, and some technical or techniques we might wanna include is fragmenting IP packets. So we're gonna fragment many fragment is it dividing divide IP packets in some parts and then send into the network so that the network won't recognize it as a malicious packet, and in the network after going they just disassemble themselves and perform the intended tasks. Okay. uh, or might be we can spoof our IP address, so we can spoof like change our IP address to something else or some IP address that the IDS is allowing. Like it's like getting an employee card. So if we get in a building, okay, and we do have an employee card, though if we are an employee or not, the guard is gonna let us through the door. It's just like they're accusing someone else address to get into the network. And other techniques include adding some bogus IPs so that whenever a request is coming from different IP address to the network, and we can use proxy servers. They can chain our IP address to different proxy servers. That is called daisy chaining. When we chain different proxy servers in line and get our network traffic passed through that to the target. And the fourth step is banner grabbing. What if we get the device to which we have to attack? We have discovered the first ports are open. We evaded even the IDS. After that, we have to banner grab like what the version of what service version is running on that port, so that we can further utilize that information to exploit the service. Okay, and then we do have to it's build network diagrams. It's not necessary if you're a beginner, but if in the process of conducting bigger scans, or we do have to say we looks like we got a big target. If we got a big target, so we have to make a proper documentation. Okay, so it can be performed. There's a tool called Martego, so we can uh, to, make a proper network diagram. Which device is there? How many networks are connected? How many networks are that the main network is divided into, and then how many devices are connected into those sub networks. That's like, and how many which ports are open on which device, which services are running on which port, and then this is port discovery. So I'll be now demonstrating how to manually do port discovery in detail. It's very pretty exciting to identify which hosts are alive and running on a network, but it is more valuable to know what services are running on those systems. Using port discovery, it would help us to lead. It could lead us to understand what those services are. There are basically three benefits of doing port discovery. If you identify what ports are open and available, that usually indicates that what type of services are available. With that knowledge of the services available, we can then take a look at vulnerabilities the server provides. The reason that port discovery is fairly easy is because, for example, let's say we have a server and a user who is sending packet to that server. So with that packet that shows up at the server, it is addressed to layer 2 of our Ethernet. So basically, there's open system interconnection OSI. There's a thing called so there are usually 6 layers. First, second, third, fourth, fifth, and the sixth. So in practicality, we do use only 4 layers, not seven. That just was a what we can say undocumented concept. Okay, so we in real life we use only four, but I'm gonna explain all seven to you. What are all those seven? So OSI was made by International Organization for of Standardization. That's just a theoretical model for network system communication. How do different systems on a network communicate through each other? Though it was never implemented. So OSI model consists of 7 layers. It is used as a reference for implementation of actual protocols. The first layer is application layer. It's application. You can search it on the internet. And the presentation layer, presentation layer. Then there comes session layer. Session layer. Then there is transport layer. Port. Then comes the network layer. Network. Then in last, data link layer. Paste here. It's data link. And in the last, I don't have space, so I'm putting up here. It's physical layer. Physical layer just consists of wires through which our data travels. So going a little more explanatory into this. So application layer is just human computer interaction layer where applications can access network services. In the presentation layer actually ensures the data integrity and data availability. The session layer coming down maintains the connection and is responsible for controlling ports and sessions. Coming down to the transport layer, it transmits the data using transmission control protocols including TCP and UDP. I'll be explaining TCP further, what is TCP and what is UDP in detail. Then there comes the network layer, which decides which physical path the data will take. Then there is the data link layer, and then it defines the format of data on the network. And then there comes the physical layer, which I have told, just transmit the raw bits between the physical mediums like wire. Okay, and one more thing, in the transport layer, the data travels in segments. Right? Segment. The data transfers as packets like IP packets, ICMP packets, etc. In the data link layer, the data transfer through frames. Very difficult to write paint using laptop. Then in the physical layer, the data transfer as bits, which already I think we all have studied in the past. Those are zeros and ones. Bits, that is 0 and 1. 0 means off and 1 means on. So through that the electric current passes in that form through the wires. Now coming back to scanning, uh, where I was. Uh, can anyone remind me where I was? I forgot.
You were at a physical layer explaining about the bits 0 and 1.
No, no, no. Before that, this
You
OSI.
were going to analyze the services by port scanning.
Okay, yeah. Okay. Thank you. So yeah, uh, basically the layer two, the packets, we send actively packets to our victim machines, and that packets shows up at the server at the Ethernet layer, that is layer two, at data link layer as frames. Okay, the server is going to de-encapsulate that information and pass it up to the network layer. So basically, there's a concept of de-encapsulation through the OSI model. Encapsulation, simple words. So basically, encapsulation is wrapping of data and function in a single data link that transfers data to the presentation layer. That the packet or whatever the data is contains the application layer data. Then in the presentation layer, the data is going to just add up. Here is application layer data, and the presentation layer is gonna add up its own data too. Then it's passed. And then there will be a total three blocks. one for application, one for presentation layer, and the session layer its own data too. Like this, the chain follows until it's reached the physical layer, and then the data is transmitted through wires to the another device. And same when the data is received at the physical layer, it transfers the data in the victim's machine with data link layer, then to the network layer, then further ups. So here the encapsulation is taking place, and here the de-encapsulation. So the data is just unwrapping itself. So here will be have what is six segments for each layer. Here we will be having 5 segments, here 4 segments, and here finally at the top only one segment. So it is the concept of decapsulation of data, de-encapsulation of data. Sorry. Okay. So when we send data to our victim, it's going to de-encapsulate that information and pass it up to the above layers till layer 4, that is called a transport layer. Okay, so if it's an HTTP request, it's going to be using a TCP. A TCP stands for Transmission Control Protocol at layer 4. And if the server is running a web service, it is very likely to be listening on TCP port 80, which means if we send a request, the TCP port 80, the server will respond and predict all the ways back to the user how data can be transmitted. And that's how user can know whether the TCP port 80 is open or available on this web server. So basically how TCP works. I'm gonna do that in detail. So let me source for eraser. So am I getting too boring? I feel like
No, no, no.
No, no, bro. You are good. Explaining things in very easy. Continue.
I talked to a policeman from UAE or Kuwait, I don't remember, and he said I am too boring at teaching things. I feel like same. You don't make things interesting.
Well, it's all about how capable they are of listening.
Yeah, might be.
Yeah, listening is also an skill. Also a skill.
Okay, so let's assume it's Bob, and here it's Louis. And same TCP connection between them too. Okay, so what Bob is gonna do, just let me first make a diagram, then I will explain. In here, I will explain what it is.
मम्मी रोटी खा लियो। I think rather than writing them down, you should write them on the go. So it's a bit more interactive and time saving also.
Yes. Okay. So for example, let's assume we do have a two devices. Okay, and on the first device we have a user named Bob, and the on the second device we have user server. So basically, we can say it's Bob is a client and Louis is a server, and the client is interacting with the server. In TCP header, there are set of different flags to indicate the purpose of the TCP segment. As I previously said, the data in the layer 4 usually uh, travels in data segments. Okay, so Bob is set his SYN flag on. So there are flags like SYN, ACK, push, urgent. There are different kind of flags. So Bob set his SYN flag, also set an initial sequence number. Let's say here it is 5. Okay, so Louis being a good telnet server, that's port 23 is well known port for telnet service. Telnet is basically a clear text data transmission protocol. It transmits data in clear text form, and uh, as by the name clear text, it's very easy to eavesdrop on. Eavesdrop means man in the middle. We can listen as a third device what two devices are talking. Like it's just like shouting in an open room. Everybody near can listen if like something like that. Okay, so let's don't go deep into that. Louis being a good telnet server, having port 23 open, responds back. Okay, so Bob asks Louis, "Are you open?" And I've set my SYN flag as 5. So Louis responds back, "Yes, I am on port number 23." And Louis sent two flags back. SYN plus acknowledgement flag that yes, Bob, I have received your message, and here it's my acknowledgement number that is 6. Here I mentioned it. Okay, it's acknowledgement number 6, as well as a sequence number. A sequence number that is 103. 103. The Louis sends to the client that is Bob. Okay. Now, also as a part of TCP header, we are gonna send an acknowledgement that indicates the next sequence number. Okay, so it's like if Louis send an acknowledgement 6, so it indicates the next sequence number. Okay, so like the SYN was 5, so the acknowledgement number will be 6. And it just indicates the next sequence number we would expect to get from Bob. So if Bob send a sequence number 5 responding with the acknowledgement back to Bob, we expect the next sequence number 6. Also, in this SYN packet is going back to Bob. Louis is also sending his own SYN request and his own sequence number also. So when Bob gets that flag from Lois, he's gonna send acknowledgement saying, "I got your SYN request and I expect the next segment to be 104." Okay, so what Bob is gonna do, just say, "Okay, I got your message and here's my acknowledgement for the message that I received, ACK, and it's acknowledgement number." So the sequence number, if we can see, not clearly visible, not at all, it's 103. 103, which Louis sent to Bob. So Bob's acknowledgement number will be 104. That is one added to Louis' sequence number 104. 4. And Bob's next sequence number, which Louis sent as an acknowledgement, and same as we expect from Bob, that's gonna be sequence number 6. So that's how a three-way handshake takes place in a in TCP, that is Transmission Control Protocol. So this is an example of traditional three-way handshake and the expected behavior when two devices are setting up TCP session. Okay, so Bob as a client and Louis as a server, they are establishing a TCP session. So how their conversation looks like is explained. Termination mechanism. So how do we terminate a session? We have created one. So how we gonna terminate them? Okay. So let's assume this data transfer happening between them.
Do anyone have any question regarding the TCP handshake and its procedure?
Yeah, you can ask anyone.
I think you explained very well. That's why nobody have any questions.
Okay, thank you. Let's assume no one have any doubts. Let's proceed further. Yes. Right. Okay. So, so let's assume there is data transmission happening between them, between Bob and Louis, that is client and server. Data transmission. Okay. So let's assume the data is transferred between both of them. And now what Bob is gonna do is say I finished data transfer. I I'm done. Short says I'm done. Done with the Louis. Don't have a connection.
I have a little bit of suggestion for
Yeah,
you.
yeah.
Rather than writing down with pencil, you can use the fonts. Just type using
Actually,
your
they are not
keyboard.
available. If you can
Okay.
see,
Okay.
feature has not been yet implemented. That
Okay.
was a bit chaotic.
Okay.
Okay,
Thank
so
you.
in the process of port discovery, we can use this behavior of TCP. Okay, so let's before move forward, let's finish this. So what Bob is gonna do, finish, I'm done, say to Louis, and then send a sequence number that is its own. Let's say it's 90. Okay. So and then Louis will say to Bob, I receive your termination request. I got your termination request, and it's gonna send an acknowledgement, ACK, and an acknowledgement number. What will be? It's a 1 plus 2 Bob sequence number. So acknowledgement number will be 91 and its own sequence number, or let's say it's 207. Okay, so acknowledgement number will be 1 plus the sequence number of Bob and its own sequence number, that is 207. Then okay, and it also sends another message as finish with finish flag. Okay, so when we have to terminate a connection, we use a finish flag. Okay, uh, and just it's gonna say another message, received all data sent by Bob, sent by you. Yeah, I got all the data that is sent. So it's gonna
अरे एक मिनट।
So all the TCP requests, they all go in a sequence, so they do not interrupt each other, right? Am I audible to you guys, or is there an internet issue?
Rahul, you are audible, but Wrath is not audible. I think
Okay.
his mic is off or something else. I don't know.
hmm I think he was connected with two devices. One device is offline and another is online.
Yep,
Okay, let's wait
think
for
so.
him.
We can ping it in the Discord.
Uh, yep. Meanwhile, talking about the TCP and stuff. Uh, how do you guys see cloud security in near future, specifically from pen testing purpose, like how to pen test stuff and
Hello.
yes, you can answer this question if you are in cloud security.